Good morning, students. Let us continue our discussion on chapter number 1, Real Numbers, part 4. In today's session, we will discuss prime number and composite number, prime factorization, fundamental theorem of arithmetic, ICF and the LCM using prime factorization. These are the 4 main topics which we have to discuss. Yes, first of all, let us discuss a prime number. All of you learned in lower classes that a prime number is nothing. It is a number which has only 2 factors, 1 and the number itself. So for example, 3 can be written as 1 multiplied by 3. The factorized form of 3 is 1 into 3 or 3 into 1. It means that 3 has only 2 factors. So we can say that it is a prime number because it has only 2 factors. Similarly, 5, 7, 11, etc. they are also prime numbers. 13 is also a prime number like this. Next, let's go for composite number. I have shown here some numbers 4, 6, 10, 22. So these numbers are not prime numbers because they are the numbers which have more than 2 factors. Say for example 12. 12 can be written as 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4. It means that 1, 2, 3, 4, 6, 12 are the factors of 12. So it has more than 2 factors, therefore it is composite number. Next, what do you mean by prime factorization? So whenever we talk about factorization, it is a process of writing a number as the product of some other numbers. So when we talk about prime factorization, then we have to write only the prime numbers as factors. Okay, so let us take one example, 10. When I take 10, then this can be written as 2 multiplied by 5. Here both the factors 2 and 5 are prime numbers. So 2 multiplied by 5 is the prime factorization of 10. But just below this, I have given here another example for 12. 12 is written as 3 multiplied by 4. Here this is not the prime factorization of 12 because 4 is not a prime number. Next, yes, for class 10, this is a new topic, that is fundamental theorem of arithmetic. In this theorem, we have to consider composite number. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. It means what? Here we have to see 2 important that is words. One is primes and another is unique. Whenever a composite number is expressed as the product of primes, that is prime factorization. Okay, when a prime factorization of a composite number is done, at that time the prime factorization where the prime numbers come out as factors is unique. It means what? Okay, suppose 12. When we factorize 12, 12 is equal to 2 multiplied by 2 multiplied by 3. Here 2 and 3 are the prime factors. 2 can be written as 2 square multiplied by 3. This is the prime factorization of 12. In another sense, it can be written as 3 multiplied by 2 square also. But this is not a new factorization for 12 because both the prime factorization 2 square into 3 and 3 into 2 square are same. It means that as these two being same, therefore this factorization is unique. We cannot have more prime factors besides 2 and the 3. Similarly, 20. When we prime factorize 20, we are getting as 2 square into 5. Or another way of writing is 5 into 2 square. But here we observe that we cannot have other prime factors like 3, like 7, like 11, etc. for 20. So it means that this factorization is unique. Next, let us find ICF and the LCM by prime factorization method. For this, take two numbers 4 and 10. So how can we write 4 as the prime factors? 4 can be written as 2 into 2, that is 2 square. Similarly, 10 can be written as 2 multiplied by 5. When we talk about the ICF, we have to consider only the common factors. Common factors with the least power. Here the power of 2, that is index of 2, for the first is 2. And for the second it is 1. And 2 is the only common factor, therefore ICF is 2. But what is the LCM? LCM, while talking about LCM, we have to consider all the factors which we observe in both the numbers. So what are the factors we observe here? We observe here only two factors, 2 and the 5. And we have to consider the highest power. So 2 square and another is 2 power 1. Therefore highest power is 2, so we consider 2 square. Then multiplied by the other factor is 5. Then later on the product becomes 20. So this 20 is the LCM. So ICF is nothing. It is product of the smallest power of each common prime factors in the numbers. Whatever the common prime factors are observed, we have to consider in finding ICF. But for the LCM, it is not compulsory that we have to consider only common prime factors. We have to take all those factors, all those different factors, but we have to consider greatest power of each prime factor. Then after that, here is a very important relation. For any two numbers A and B, ICF multiplied by LCM is equal to product of the numbers, that is A and the B, A multiplied by B. This relation is always true for any two numbers. Then let us discuss some questions of exercise 1.2. Express each number as a product of its prime factors. It means that you factorize this in prime numbers only, that is prime factors only. Let me leave Roman number 1, 2 and 5 for you as homework. Then let us consider Roman number 3. What is the number here? The number is 3825. So when we factorize as we did in lower classes, then we are getting factors 3 occurs 2 times and 5 again occur 2 times and 17. Then later on we have got like this. Similarly for Roman number 5 also, the factors are 5, 7, 11 and 13. These are the prime factors. Okay, yes. Now you practice these questions. Question number 1. Express each number as a product of its prime factors. 140, 156, 7429. These are the 3 questions left over from question number 1, exercise 1.2. Then question number 2, find the LCM and the ICF of the following pairs of integers and verify that LCM into ICF equal to product of the numbers. The first one is 26 and 91. The second pair is 510 and 92. So you find the LCM and ICF by prime factorization method, and after that you show that multiplication of LCM and the ICF is equal to the product of the numbers. Okay, thank you all.